Coal pollution mitigation, sometimes called clean coal, is a series of systems and technologies that seek to mitigate the health and environmental impact of coal. In particular, air pollution from coal-fired power stations and from coal burnt by heavy industries. In this topic, we tackle about conventional and clean coal. In this topic, we will discuss about the burning and the current use of coal, clean coal technologies, is clean coal actually clean, and a summary. So, coal is classified into four main types and is ranked accordingly: lignite, subbituminous, bituminous, and anthracite. The ranking depends on the types and amount of carbon the coal contains and on the amount of the heat energy the coal can produce. Lignite or brown coal contains 25% to 35% carbon and around 70% when dry. Bituminous contains 35% to 45% carbon. Bituminous contains 45% to 86% carbon, and anthracite or black coal contains 86% to 98% carbon. In this slide, we have some specimens of coal. On the upper left corner, we have lignite, often referred to as brown coal. It is a soft, brown, combustible sedimentary rock formed from naturally compressed peat. It is considered the lowest rank of coal due to its relatively low heat content. Next, in the upper right corner, we have subbituminous coal. It is a type of lower grade coal. The properties of this type are between those of lignite, the lowest grade of coal, and those of bituminous coal, the second highest grade of coal. Subbituminous coal is primarily used as a fuel for steam electric power generation. On the lower left corner, we have bituminous coal. It is a relatively soft coal containing a tar-like substance called bitumen or asphalt. It is of higher quality than lignite and subbituminous coal, but of poorer quality than anthracite. And lastly, anthracite, also known as hard coal or black coal. As it is a hard, compact variety of coal that has a submetallic luster. It has the highest carbon content, the fewest impurities, and the highest energy density of all types of coal. And it is the highest ranking of all coals. Coal and electricity. Coal-fired plants produce electricity by burning coal in a boiler to produce steam. The steam produced under tremendous pressure flows into a turbine, which spins a generator to create electricity. The steam is then cooled, condensed back into water, and returned to the boiler to start the process over. In 2002, fossil fuels released 23 billion tons of carbon dioxide into the atmosphere. Of the 23 billion tons, 41% was from coal. Burning 1 ton of black coal, you can get 4 tons of carbon dioxide, with other coals averaging 2 tons of carbon dioxide. Anthracite releases 67% more carbon dioxide than methane, and brown coal releases 130% more carbon dioxide emissions than methane. Coal also contains trace amounts of sulfur and nitrogen that when burned can cause environmental issues. Why is coal still used? It is cheapest for power stations relative to the amount of heat it generates when burned. It is also by far cheaper than nuclear, natural gas, and oil. Although alternatives like hydro are usually slightly cheaper, problems with hydro include no new facilities because of public outcry when river valleys are dammed and peak demand time problems, such as rivers running dry in the dead of summer when peak air conditioning is needed.
Why is coal still used? It is said to be the cheapest for power stations relative to the amount of heat it generates when burnt. Here are the cheapest options. Graph shows that from 1999 to 2007, coal still remains the cheapest amongst all the options. And so, how does a coal power plant work? Coal-fired plants produce electricity by burning coals in a boiler to produce steam. The steam produced under tremendous pressures flows into a turbine, which spins generator to create electricity. The steam is then cooled, condensed back into the water, and returned to the boiler to start the process over. And so, what is clean coal? It is actually a vague term that does not describe any one process. It can include the removal of nitrogen and sulfur that creates acid rains. It can include the storage of carbon dioxide. The term clean coal is abused. The clean coal technologies includes coal washing, wet scrubbers, low nitrogen oxide burners, electrostatics precipitators, gasifications, carbon captured storage or CCS, fuel cells, and magnetohydrodynamics. These will be tackled in the next slides.
Hello, this is Ken John Atis reporting. Coal washing. Grinding coal into pieces and passing it through gravity filtration. One technique, putting coal into a barrel with a liquid with a specific density where the coal floats and the impurity sinks. Also, coal cleaning by washing has been standard practice in developed countries for some time. It reduces emission of ash and sulfur dioxide when the coal is burned. Wet scrubbers. Wet scrubbers can remove particulate matter by capturing them in liquid droplets. The droplets are then collected, with the liquid dissolving or absorbing the pollutant gases. A scrubber works by spraying a wet slurry of limestone into a larger chamber where the calcium in the limestone react with the sulfur oxide in the flue gas. For example, some scrubber may use other chemicals such as lime or magnesium oxide to react with the sulfur oxide in the flue gas. Some disadvantage of wet scrubbers includes corrosion, the need for entrainment separation or mist removal to obtain high efficient, and the need for treatment or reuse of spent liquid. It's also a 99% effective. The gypsum is collected and used for construction too. This one. Nitrogen oxide. Stages in using nitrogen oxide in clean coal technology. First stage, combustion occurs in an oxygen deficient zone where nitrogen oxide is usually formed. Second stage, hydrocarbons are formed which reacts with the already formed nitrogen oxide. Last stage, the third stage, internal air staging completes the combustion but may result in additional nitrogen oxide formation, which can minimize by completing the combustion in an air-clean environment. Electrostatic precipitators creates an electrical field that removes unwanted charged particles. At cross-section, electrodes cause particles to become negatively charged. The negatively charged particles attract to positive charged plate. Then the flue gas passes through the cross-section. Then the particles fall into the hopper. Then the flue gas has been cleaned.
Gasification. Gasification is a type of thermochemical conversion process which is being favored by some because they are very flexible and have a high levels of efficiency. So, it uses heat to convert a biomass or a fossil fuel-based materials into intermediates like the hydrogen and carbon monoxide rich gas called the synthetic gas, or in short, the syngas. Syngas is cleaned and burned, which then turns a turbine. As gas is being cooled, it heats also the water, in which it turns another turbine. Gasification is known for its advantage over the combustion for its emission control. Here is an example of a gasification power plant. The numbers shown are the processes for which the gasification power plant is being processed. The first process is that coal is being burnt to produce the syngas. Coal is added together with the oxygen and water to produce the syngas and has an output of slag. This syngas is being burnt in the combustor in the second process. This syngas is being heated to produce a hot gas. This hot gas drives the gas turbine, which is located at the third process. The gas turbine produces the electricity as its output. Then, the gas is being cooled down and goes to the fourth process, for which the cooling gas heats the water. This cycle of water produces the steam, which will turn the steam turbine at the fifth process. Then the cooling gas will exit through its exhaust. Gasification is seen as part of a zero-emission system. It improves the sulfur dioxide and nitrogen oxide emissions, which is already very low. Although it is widely used worldwide, it is unproven on a widespread scale. It has an efficiency of over 45%. Currently, it is only demonstrated on a trial basis. So, right now, it is expected that syngas is being cleaned at low temperatures. For the future, it will be cleaned at higher temperatures, increasing efficiency. The gasification power plant is also very costly, but the current coal power plants can be modified to increase the efficiency, reduce production cost, and its durability. Carbon capture and storage. It is the capturing and storing of the carbon dioxide and storing it underground. This process is what we term as the geosequestration. It can capture up to 90% of the carbon dioxide released by the process of burning fossil fuel. The figure shows are the options for carbon capture and storage. 1. Coal is pumped into these used coal fields and displaces methane, which can be used as a fuel. 2. Carbon dioxide can be pumped into and stored safely in the saline aquifers. And 3. Carbon dioxide is pumped into an oil fields, helps maintain the pressure, making extraction easier. There are many problems with the CCS. Carbon dioxide is very hard to capture because carbon dioxide in nature is a gas which is highly toxic. Once captured, it needs to liquefy, which takes the 20% of the energy yielded from the coal. Where the CO2 is stored needs to be monitored. The carbon dioxide is then stored in carefully selected geological rock formations that are typically located several kilometers below the Earth's surface. So it is being transported by the pipelines or by ships. There are only so many places that are good for mass storage. This transportation could also become costly. At every point in the CCS chain, from production to storage, industry has at its disposal a number of process technologies that are well understood and have an excellent health and safety records. The commercial deployment of the CCS will involve the widespread adoption of these CCS techniques, combined with robust monitoring techniques and government regulation.
Fuel cells allow hydrogen from coal to react with oxygen to produce electricity electrochemically. Specifically, hydrogen is produced by first reacting coal with oxygen and steam under high pressures and temperatures to form synthesis gas. A mixture consisting primarily of carbon monoxide and hydrogen, and it is costly. And this picture shows how fuel cell works. So first, hydrogen reacts with catalyst when it reaches the anode. Second, this makes positively charged particles that go through the electrolyte and electrons that travels along a circuit make an electrical current. And lastly, when the particles and electron reach the cathode, they react with oxygen to form water and usable heat. Magnetohydrodynamics. Coal is burned to form an extremely hot gas or plasma, given an electrical charge by adding a compound like potassium salt. The charged gas or plasma is passed through a magnetic field and electricity is produced. The heat from the combustion gases is used to turn a steam turbine, and it is costly. So is clean coal really clean? Unfortunately, there's no way to make coal clean. Processes like gasification can make coal burning more efficient, but it still burns plenty of carbon dioxide. Carbon dioxide can be stored underground using CCS, but that could lead to more problems in the future. Summary. Coal is very inefficient and is a huge cause of global warming, but it is cheap. Clean cool is a term that describes many different technologies, and clean cool is by no means clean. And lastly, CCS will be put in use in the near future, which may or may not be a good thing. That's all. Thank you.